Hello and welcome. My name is Tim Pizarro. Today I'm going to present to you my Python solution to the classic dark maze challenge. Why Python? I wanted to learn an object-oriented language. There are many candidates. I chose Python because it's used by OpenStack, which is a cloud computing platform. I needed a course. I picked this one, unsurprisingly called Think Python. This is the comprehensive 20 chapters of Think Python. It's clearly written, and there are exercises, including the answers to the exercises. I used the Elastic Path Developer Challenge as a source of dark maze problems to solve. The Elastic Path Maze server provides a REST Level 2 interface to the maze. This page describes the API. There are commands including init, which creates a new maze that exists for 5 minutes, which of course means you need to solve it in 5 minutes, as well as commands to move around the maze. And then the description of the JSON response from the server, as well as an example of that syntax. I chose the Tremaux algorithm to solve this classic maze problem. It was formulated in the 1800s. It converges quickly, and it has 4 steps, which are shown in this diagram. I found the diagram of the 4 steps of Tremaux' algorithm on this site. It also has an example of the implementation below, where it solves the maze. I found this implementation of the Tremaux algorithm written in Python in GitHub, written by Brendan Wilson. Review of this prior art will help me writing my own code. I loaded Brendan's code into PyCharm, which is a Python IDE. Why PyCharm? Well, of the 21 IDEs, Python IDEs listed in Wikipedia, it had a recent release, and it was recommended to me by a person I met at a Python meetup. Following the agile principle of minimum viable product, my code was much simpler than the previous examples. 2 classes, a maze and a cell, and the maze having a data structure which was a dictionary of cells, using XY coordinates as a tuple for that dictionary key. This is important because Python uses a hash table for dictionary lookup, and that key has to be immutable. In other words, you cannot change the values once they've been created. I also have nits to initialize the attributes of both the maze and cell when they're first instantiated. Here is the UML class diagram for my 2 objects. On the top, we have the attributes with their initial values set through the init method, and below we have the methods. Note that the first 3 methods here and these 2 methods here are for printing to help analyze and debug and track the progress. The methods below here, walls, this is finds all the walls for a particular state. This allows you to write to walls to update the current status of a wall. This finds adjoining walls for the current cell, and this path method is the Tremaux algorithm for navigating the maze, and then backward and NRV are used within path. And then on this side here, the hgetToCell is a method which takes the status from the API and writes it into the local copy and updates the status of the cell, which is listed in these attributes here. This is my code in the PyCharm IDE with the path method of the maze object expanded. Executing the Tremaux algorithm, you have the first part where you continue to follow unexplored walls in the cells, and then when this creates an exception, meaning that there are no more unexplored walls to follow, you come down here and then you figure out which cell to go back to. And below you here, you see I've run it and I reached the end. Success. So here we are at the end of the log file after successfully solving the maze. You can see we get the congratulations note here, and you can see that the end is equal to true, and I think I even have it here. Yes, we have this is the output from the API that's been written directly, which says at end equals true. A few observations about Python. 1. Looping. Boy, is it ever easy to loop through items in a sequence. You don't have to initialize or specify a limit. You just choose an object from that sequence. And an example here is in my NRV method, where I have direction, which is in this list of visited directions, and I just say for direction and visited, and then you can see I get to use direction as an argument all the way through. Very, very easy indeed. Another observation about Python is exception handling and the fine granularity that you have available to trap specific exceptions and, in fact, use them as part of program flow, which I did in this case, where if this list here is empty, in other words, there are no unexplored walls, that creates an exception. And that's where I come down here and decide how to backtrack. A final observation is dynamic typing. So types are set at runtime. That is, a variable name is not tied to a type, and that it may be assigned to different types during runtime. And the really interesting capability here is that it allows method and function polymorphism, which means that you can write a method that might work for strings, and of course it will probably work for any type of sequence. Very powerful indeed. This concludes my video. If you have any inquiries for me, please contact me through my LinkedIn profile. Thanks for watching.